What's up, everyone? So we're back again with the AP Calc series of a cram review that I'm going through quickly about the basic stuff from examples and a little bit of notes. This won't have everything, but it's like a really quick, short cram review, especially with my final later on today and with the AP exams approaching. Okay, so now we're doing graphing derivatives. This is like the first derivative test. I'm gonna split up into 2 or maybe 3 videos here so we could go quickly. Okay, so when you're given a function, let's say just something like this, and let's say this is the derivative, okay? And you see we have our extrema there, but this is not the function actually, it's the derivative. So we see from this point here, let's just say A is here, and then B, C, so those are the points where the graph is hitting and going through the x-axis. So let's put those over here too. Okay, so we see it's negative, then positive, then negative again, all the way, and then positive, where when f prime is negative, f is decreasing. When f prime is positive, f is increasing. And so I drew, let's just do this portion right here where A and B are this half of the graph. Okay, so from negative infinity to A, we see that's negative in the derivative. That means it's decreasing. And then with positive, so it'd be like decreasing like this. It would be having a negative slope. Then if we go from A to B, it's going to be increasing because it's in the positive. So that would be, and it looks like a point of inflection would be here. A point of inflection would be that horizontal tangent. You could get back into that. Now, I think let's just get started with the first derivative test. So just disregard all this for now, except for this. This is what we're kind of looking at. And then you could also play around with extrema, which we could also do later. And then also there's the second derivative test. Okay, so let's get on with the first derivative test. Let's start with this example. F equals negative 5x squared plus 30x plus 7. And right away we're going to get the derivative of this using the power rule. And negative 10x plus 30. And if we quickly solve for this x to get our crit value is the value we're going to be testing the derivative, and it's when f prime is equal to 0. It's at these x's where f prime is equal to 0. So like in our example here, the f prime graph, it would be at A, B, C. So here we're just going to solve this for x, and if we do that, we get x equals 3. So that's our crit. So now what we're going to do is make these intervals with 3 in the middle, a number larger than 3, a number smaller than 3, and now we just test the first derivative. We're going to test the first derivative's positivity or negativity. So when we do f prime of 0, we get 0 plus 30, so that's a positive. If we do f prime of 4, we get negative 40 plus 30, which is a negative number. So from 0 to 3, the graph is increasing. The graph of f, of regular f, is increasing from 0 to 3, and from 3, sorry about that, 3 to infinity. Actually, this would be negative infinity. I'm sorry about that too. So from where the derivative is positive, it's going to be increasing in the graph of f. Where it's negative, it's going to be decreasing. So this is decreasing. Okay, so and f also has a max, a relative max, A relative max would be something, let's say we have a graph like this. A relative max would be, let's see, this number, this point right here. Relative min would be something like right here. It's not the absolute. If it was the absolute, it would be something like that. That's an absolute min. But since there's other points that are lower in this graph, it's just relative. Okay, so back to our example. F has a relative max at x equals 3. So now we get to our regular function and we plug in 3 for all the x's, and we get 52 as the y coordinate. How did I get to f has a maximum? Well, a maximum will occur when the function f is increasing to decreasing. Wherever this value is, where it's increasing, then at the value, and it's decreasing, that's a max. When it's a min, f would be decreasing to increasing. Right, so that's the first derivative test. Thank you for tuning in. Please look at more examples and stay tuned for more graphing videos, especially the second derivative test and the other concavity stuff. Right, have a good day and do something nice for someone.